Hello, everybody. Welcome to the second session of IBC Continuous Education Program, Module 2. Thank you for joining us. We have Mr. Selva Raju with us today to continue the Module 2 sessions. We will be beginning at 7:05, so in 2 minutes we will start. Thank you. Guys, we're going to get going. So without wasting any time, I'm going to hand it over to Selva.
Good evening, ladies and gentlemen. Welcome to this session. Okay, so I see Puneet has actually. Puneet, are you there? So the assignment he has submitted. Okay, here in the chat window. So just to start, what I'm going to do is I'm going to show you his code in there. So let me just create a new project. Cargo. Okay, just a minute. I need to share my screen. Okay, are you able to see my screen? Deepak, is my screen visible?
Yes, sir.
I hope everybody is able to see my screen.
Yes, sir. We can continue.
Okay. So I'm going to create a new project there. By the name CEP session 2, and I'm inside this project, and now I will launch Visual Studio Code. Okay. Here is our main RS file. Okay, so right. So first off, actually loading all the plugins, about check, indexing, all going on in there. Okay, right. So Rust Analyzer is done with. Okay, so now, so this is Puneet's code, right? I'm just going to copy this. So Puneet, are you there?
He has responded in the chat window.
Okay. So I'm just going to copy this and okay. This, open up a terminal. and run this. So that's it. Now again, cargo run. So 10 is big, right? Okay. So Puneet, your code seems to be working. Okay. So let me see Puneet's reaction. Okay. Right. So now basically what we wanted is that you give three numbers and then what you do is basically find the maximum out of it. So if number one is greater than number two and number one is also greater than number three, so you just display number one. Otherwise, so which means that number one is not greater. So basically, it has to be one of the number two or number three. So you just compare number two and number three, and you get the big number. Else, you just print. So if there's a number two is the biggest one, and obviously in this else, number three has to be the biggest one. Fine. Okay. So Puneet, good job. Now see what I'm doing is I will change this 5 to 10 and I save this. Okay. And now if I do a cargo run, is it right? So and if I give 10 here also, okay, and if I do cargo run, 10 is big. So what you should be doing is that basically you should do all the combinations in order to understand. So what I've done basically is that I have run this code with all kinds of possibilities. Okay. And you need to ensure that the code runs. Okay. That's how you do that. So even if the numbers are the same, so that means number one greater than number two, if obviously this will fail. It will go in here. Number two is greater than number three. This condition will also fail. So anyway, number three is the greatest, which happens to be 10. So even if all the values are the same, okay, we'll still get the output. Okay. Good job, Puneet. Very good. So this is one way of looking at it. And in the assignment, I also showed you to, I gave an assignment wherein you have to find the minimum of 4 numbers. Okay. So please do that and submit it, and we will take a look at that. Okay. So Puneet, good job there. Right. So today what we are going to talk about is a little bit of the variable immutability, which is something that is must be really understood. So suppose for instance, if I have a variable, let's say let n is assigned 99 and I just print it out, okay, and in fact so value of n is, and then we put a curly braces here as a placeholder and give n, save this and do a cargo run. Value of n is 99. There's another way of doing it. If you have the variable, you can actually inject the variable name itself in here. Okay, you can do it like this as well. If I do a cargo run here, okay, it's still display. Okay, so if you have the variable names known to you, you can directly inject that in the placeholders and the value will appear. That is one thing. Okay, now what I do is I want to increment this to 100. So let's say I do it like this. When I say n is assigned n plus 1 and display it. Now the moment I save, I start getting squiggly lines. So it says, hey, cannot assign twice to immutable variable n. So let me just show you in here. So cargo run. Okay, there you start seeing this error. First assignment to n, So let n is 99, that's fine. Help consider making this binding mutable n, because the problem is when you start to change the value, it says cannot assign twice to immutable variable. Now this is where Rust is quite different in terms of working when it comes to programming languages. Okay. Now variables in Rust are immutable. Okay. So one important aspect that you have to understand in Rust is immutable. Okay. Immutability means that you cannot change the value of a variable. Okay. You cannot change the value of a variable. So which means that calling it variable itself is a misnomer of sorts, right? That's true. So what actually happens is that now Rust has this built-in mechanism for memory management and also to make this code as error-free as possible. So suppose, for instance, if you need a variable that needs to change its value, okay, during the lifetime of the program, then in that case you cannot use just let n, it will not work. Instead, what you will have to do is you'll have to say, hey, you have to tell the compiler, hey, you know what, I'm creating a variable, but I want this not to be immutable but mutable. So you have to add the mute keyword in here. That's MUT. And now you see that the error is gone. And in fact, if I come back to the terminal and run the code, so first the value is 99 and now it has become 100. Okay. So you have to be explicit. So what is the difference between a variable which is immutable and a constant? So you might ask. Okay. So if you want to create a constant, you can always do so. Okay. So you can just say const. Okay. And then give the variable name. So let's say I call this as pi and 3.14. So if you do it like this, then what happens is here you can see this. It says by syntax error missing type for constant or static. Okay. So whenever you define constant for a variable, you need not mention the data type. It will get inferred by the compiler. But whereas in case of a constant, okay, you have to provide a value. So I'll say F32. Save this. Now you still see errors. So it says C here. The mutable variable reference to pointer mute can be used in several situations. The first is mutable variables, which can be used anywhere. You can bind a value to a variable name, some examples, and so on. Okay. So mutable variable reference or pointer. Okay. So what is happening is if you want to use a const, okay, compile time evaluable functions. Okay, other uses of const keyword is used to raw pointers in combination with mute. Okay, turning a function into constant function, right? Constant values. For more details on const, you can use the Rust book. So you can actually check in the Rust book also. So let me just show you here. Let's just search for. So there it is. Constant. So when you define a constant, what you have to do is you have to use the name in uppercase letters. That's the convention. You have to follow that. So the mistake that I made was, which was actually deliberate. So I'll change this name from pi to pi all caps. Okay. Now, I've not made use of this value, so it's never used. So that's just a warning. So whenever you create constants, you have to take the name in uppercase only, all uppercase. Okay. And if you have multiple words in it, so you have to use the snake casing by putting up underscores in between, right? This is one thing. So if I take an immutable variable, okay, and I take constant, then what is the difference? So essentially, you can think of it like this. So let's say I define another variable, okay, area. Let radius is assigned say 2.5, something like this. Let's say let area is assigned okay, pi times radius times radius, as you can see here. And if you save it, that error will be gone. And area is not used, so I'll just print it out. Okay, client area of circle with radius, and I can use the name itself is area. Save this, and let's go to the terminal and run this and see. Works fine. So, and if you have an immutable variable, which is basically sort of a constant, it's sort of a constant, it's not exactly constant. So, what is the fundamental difference? The fundamental difference is basically what will happen is that if you create a constant pi with this value 3.14, what the compiler will do is that wherever it finds pi, it is going to inject that value, and in fact, in your object code or basically the executable, there is no such symbol by the name pi. Everything has been replaced by the value that actually provided. That's one difference. Second difference is that, okay, when I'm creating the variable like this, even if it is a mutable or immutable variable, so okay, let it be here, and I define a variable like this. I can also define a variable like this and say let okay x, and then I say x is assigned 55. Okay, so it has inferred. Now variable x is say here it is assigned to but never used. Okay, so for this you have to add the annotation unused variables. Okay, and then in here the value assigned to x is never read, so that is another warning. Okay, so that shouldn't be a problem. So if it is a variable, you can just declare the variable, not define it, and then you can do an assignment. Okay, and then you can do an assignment. Whereas with constant, an assignment is necessary. So whenever you define a constant, you have to, you know, define these. I mean, provide the value. So that is something that you have to keep in mind. Okay. Whereas for regular variables, even if they are immutable, also you can just give declare them like this, and then finally give an assignment. So it will actually wait for the first assignment to happen. So let me just add this unused verse. So hello unused. Okay. Here it is never used, so that's fine. It's never read. So if you just put it in some expression, it will be work. It will work just fine. And now if I did something like this, okay. So um, let's say I do it like this. X is assigned say 88. Okay. And if you save this, you will start getting error in the entire statement. See, cannot assign twice. So the first assignment is accepted. That's because you did not initialize it. Okay. Right. And the second assignment will fail because it's a immutable variable. This is a subtle difference if you're coming from a regular programming language, and you have to keep that in mind whenever you are actually using Rust. Okay. Right. So let me check if there are any questions. How to declare an empty variable and after store. So I think that answers your question, Puneet. Okay. This is called as binding. So in Rust we call this as binding. So you can create an empty binding. So we call this declaration as empty binding, and then you can give the value later on. But then again, only first assignment is allowed. Subsequent assignments will not be allowed because this is an immutable variable. it would be allowed in case if you make this as mutable. Save it. So you see the error is gone, but the warning still says that you have not used the value of x anywhere. Okay, so that is just fine. So we know that we're just playing around with this code. Okay, right. Okay, so now today what I want to discuss is all about the loops, and I'll be giving you an assignment as well. Okay, so just commented it out. Okay, and we will talk about loops. Right. So loops in Rust come in three different flavors. There is a loop statement. Okay, there is a loop statement. There is a while statement, and there is a for statement. Okay, so these are the loops which we actually use in. Now, loop is, if you see here, it's actually an infinite loop. Okay, whereas while is a conditional loop, and for is a iterator loop. So all these are three different flavors. Okay, and probably the most loops you will see would be in the form of either while or for. Loop is also used, but because loop inherently is uh, an infinite loop, so you need to ensure. Okay, so ensure the use of break statements to terminate the loop at some point. Okay, that's very essential. So otherwise, this will become an infinite loop, and it will go on and on and on and on and on. Right? Okay. So what we will do is we will take a simple example of generating, multiplication tables. So generate multiplication table. With different loops. Okay. So first, let's take the loop statement. So let's say I have a value called say let n is assigned. Let's say I want to generate the mathematical table for 5. Okay. So I'll just create a counter. So because counter has to run from 1 to 10, so it has to be mutable counter, and it starts with 1. Okay, and it's a loop, and what I'll do is I will display the value. So incline, I have number, and let's say multiplied by number equal to image. Now see, in the last placeholder, there is an expression coming. So therefore, I cannot put expressions inside that string, format string. Okay. So I have this n and I, or maybe I should just make it as I. And n times I. Okay. And also I need to increment the value. So I is assigned I plus 1. And then I need to check. Okay. So if I is greater than 10, break. Okay. Or exit early from a loop. Yeah, that's fine. So let's come back up here and run this. What happened? Oh, sorry. I need to place it in curly braces. Right. See that? So we get this. So you have to ensure that you make use of the break statement, okay, in order to break the loop at some point in time. This is your loop statement. Okay. Now, if I were to do the same thing with the while, okay. So let's say I'm just comment this out. Using a while loop. So again, I say let n is in 5. Let the table I is in 1. And then I write this. While I is less than equal to 10. Okay. And then so what I'll do is I'll just take the statement. And I can also write compound assignments like this, I plus equal to 1, which is I equal to I plus 1. So there's this, and let's run this and see. Right. Okay. Oh, parentheses are not needed. So if I put it gives me warning, hey, you know what, you don't really need these parentheses. Okay, that's what it's saying. Anyways, there you go. Right? Okay. Now, if I want to use the for loop, then it will look like this. So I'm going to comment this out as well. Now, as far as for loop is concerned, it uses what is called as ranges. Okay. So I have let n is 0.5. Okay. And then say for n, sorry, I in it's a range. Okay. And then I can write whatever value I want. So I can just take the print statement and put it here. Okay. And I don't need to increment that because it automatically takes the values. However, there is one little catch though. Okay. So let's check this out. It only displays up to 9. That's because a range 1 to 10 defines a range, okay, which starts from 1 and then goes all the way up to, but not including 10. So this is called as inclusive exclusive range. That means the last value is actually excluded. If you want to include this inside of the range, all you need to just put an equal to symbol there. This makes it inclusive range. So if I do it now, there you go. Okay. Right. Okay. So any questions, please, at this stage? To store value in variable with our input screen. Puneet, I showed you last time with the IO std, right? With the IO library. Remember that from the previous session? How to use that? Okay. And for your sake, I can do one thing. We use the IO std in. Okay. You have to import, basically use the stdio. Okay. And then you can start using it. So let me just, since you asked, I'll just. So if you see here, what you need to do is you have to take the input. Okay. std, you read the line, and then now if you want this to be passed into an integer, so you can pass it into an integer, and then we use the expect. Okay. So suppose, for instance, so first take it with the index, and take that index, and then you do a trim and parse. Okay. So you could do like that. So let's say I want to take this number n, okay, as an input. So what I can do is I can say use stdio, and we want to take the n as an input. So what we can do is, so you see the previous case, what we've done. So we take the index, and if you see the index, it's actually defined as a string because it will always be a string, whatever is input from the standard input. Okay. So let so, and it has to be mutable because it will change, right? So mutable put is find string new. Okay. And then say IO std in, okay, dot read line, and pass in our, like we're done. So, but it also has to be a mutable reference in there. Okay. So sorry, I always have this issue. Reference to immutable. Okay. And we also need to use dot expect. Reading value. Yes. And generally what we do is we just and now what you do is you take this input and you parse it into so our n for our n what we do is we take so we take the index and then trim it and then parse it and then also do an expect so that the parsing actually gives you the right result. Okay. So I have input dot trim dot parse dot expect and save. And since we want to do a parse, so we need to define the exact data type so that the Rust compiler knows what type to pass it into. So this is something that you have to keep in mind. Okay. Right? Because if you see the parse, okay, it will return a result type with some function and then string, right? Okay. So now if I here I can display and okay. Instead of print line, I'm using print so that the cursor stays on the same line. Okay. So I will run. So if I give let's say 10, and I get 10 times 1 is this. So this is the way to do it. Puneet, what is the confusion here? Is it clear to you or not? Is it clear now? Okay. Any other questions, please? Other questions? Okay. Comment these lines as well. Okay. Right. So now let's discuss something about the functions. So when when you see these functions, okay, they behave exactly the way you see in other programming languages, but there are certain subtle differences that you have to keep in mind. Um, I'm sorry. Okay. Yeah. So now, what you have to do is you have to understand one basic thing in this, okay, and that is there is this concept of ownership, which is actually you know sort of uh, a little tricky, but it's not that difficult. But yeah, you will need to understand how things actually work in Rust, okay, and ownership is a big topic that you should really understand, okay. So we will see that in the upcoming sessions, and you will be able to understand it fully. So first off, let's see how we define functions and we make use of them. Okay. So in general, if you see in Rust, there are two types of functions. One is called as a function. Okay. It's actually named block of code that returns a value. Okay. And there is something called as procedure, which is again a function only. Okay. Named block of code that does some work but does not return a value. And there's a third type which is called as method in Rust. Now these are Rust specific, terminology. So about the, what to say, methods, we'll be seeing it in the next section. What these methods. So methods are basically associated with structures. Okay, the structures that you have, and since you all might already be knowing C or C++, where we make use of these structures, right? So it's the same concept. But the internal working is a little different from what you would see in C and C++. Okay, right. So I have my function main, which is the entry point into the program, and apart from that, I can define another function. So let's say, so to define a function, use fn followed by the function name. So let's call this function as welcome. And how you do that is welcome and then put a parenthesis. Okay. And all this does is, so this is a regular function that does not return a value. Okay, so aka it's a procedure. Any function that does not return a value is actually a procedure. And why we are not returning a value, instead we are just doing something. So what that something is, simply I'm going to use print line. I'll just say welcome to program. Okay, and inside the main, what I'm doing is I'm actually calling the function. So to call the function, simply use the name and put the parenthesis in there, and go to that. That's it. So now let's run the code and see. I will run, and you see welcome to restaurant. Okay. Okay. Now I can also pass in data into it. Okay. So let's say fn welcome user, and it takes in a slice. Okay, so I client welcome, and then oh, I'm sorry. So it's welcome user is never used, so that's just fine. So now what we will do is we'll call this and call this. Sorry, I'll say welcome user, and I'll pass in John Doe. Save this, and let's run this and see. It says welcome John Doe. Now this is a special syntax that you're string with the string. Okay, ampersand str. Now don't worry about this. You will understand it as you go on. Okay, so just understand this is what is called as a string slice. So when you want to pass in, what to say, a hard-coded string, then you can use this string slice. So that's the data type. Okay, string slice. Okay, and let's say you want to pass in welcome user, and then you want to also give in the age. So I'll say age, I'll say I32, and you are age okay. So here I am using empty placeholder, so name will be injected here, but here I have already given the name. Okay, age for this variable. Okay, and so here I say John Doe, and I say 45. Save this. Okay. Oh, I'm sorry. And then let's run this. Okay. You can use a combination of empty placeholders along with this. So if you already know the names of the variables, you can definitely put that up. But the only thing is you cannot put, okay, like for instance, there is something that you have to understand. You will be, and then let's say age +1 years old next year. If I try to put it like this, see, I'm getting another invalid format string expected. So found this, but it actually found this. So you cannot put up, you know, um, expressions inside this. Okay, so this is something that, so that's where, so if I want to give this expression, so what I need to do is put empty this placeholder and put the expression here. Okay, and now if I save this and try to run this, this is fine. So you'll be 26 years old next year. Okay. So these placeholders can only hold, can either be empty or you can have variable names. That's it. You cannot write expressions inside of those. Okay. Now let's build some functions. So this is again procedure again. Okay. So this would be a function takes in parameters and arguments actually. Does not return value. That means this is also a procedure. So any function you have defined that does not return a value is actually a procedure. Right. So now let's define a function, okay, that returns a value. So simplest form would be something like this. Say fn, let's say I'm doing a function called test and I return the value say 5. Okay, that's it. I just return one single value. But if you are doing a return, then obviously the function's declaration must explicitly say what type you are returning. How do you do that? So after the function's header, so you put an arrow symbol and say, okay, I'm going to return an I32. And you save this and that's it. Of course, we are still seeing that it is never used, so that's just fine. Okay. So now in the main function, let's test it out. Okay. So say line function return, and then now function calls cannot be done in the placeholder, so it has to be separate. Yes. So what will happen is the function will be called and this will get replaced with a value and that value will finally get injected into the format string. So function returns 5. Okay. Now the return statement, as far as Rust is concerned, is really not necessary. So you can simply omit this return and it will still work. Okay. The only thing is that you'll have to remove this semicolon after that. Okay. So what happens is you can just write an expression. Okay. So the expression at the end of the function will automatically become the return value. But again, remember, it's very important that Rust, how it defines an expression is that the expression does not have a semicolon at the end. If you put semicolon at the end, you'll start seeing all kinds of weird error messages. Okay, so if I put this in here, I say this, now see it says 32-bit signed integer type, mismatch type, 32 found, but actually found this function call and so on and so forth. Implicitly returns a function call as its body has no tail or return. So this is called as a tail expression. Okay, so now remove this and everything is just fine and you can actually check this out. So this is called as a tail expression. So let's do one thing. We'll call this transfer value and return 5 like this. Using return statement. We'll write another function as a test2 that just returns a value say 1, 2, 3, 4. and since it is returning, so obviously I have to put return type I32 and say the returns value using the tail. Okay, so as a tail expression. Right. Now, and what are we for this? Test2 returns this value. So you can see both the syntaxes in the source code. Test2 is returning 1, 2, 3, 4. So test is returning through the return statement, and test2 returns with the tail expression. Okay. Now tail expression need not be the last statement in the function. Okay. Say for instance, let's say I'll write a function. Says, even or odd, and it takes in a value. So let's say it takes in n, which is of type I32, and it returns a string reference. Okay. If n mod 2 equals 0, okay, I'll just return. Even see, I'm not putting any semicolons in there. Okay, else all. Okay. Okay, so I think let's return a string and return. Okay. From hard coded string, we can return. Okay. And okay, here. So incline, let's say uh, 5 is, and then there's even a rod and passing 5. And incline 10 is given a rod and passing 5. 1, 5 is odd, 10 is even. So I'm having, so I'm actually using tail expression. So basically within the if block, I'm just writing this as an expression. So this expression becomes the return value. If the condition is false, then this is again an expression. So this becomes the return value. So it's actually very flexible in that sense. Okay, very, very flexible. Okay, so any questions at this stage, please? The conclusion is too complicated to read a value from output stream. Practice, or practice. Yeah, definitely. No, you can think of it like this. See, Puneet, you're saying um, so here the conclusion is that it is too complicated. No, it's not too complicated. Puneet, have you done any Java? So in Java also we use data input streams, right? That reads a line. That line needs to be converted using the parse function, and then you get the number. We are doing the same thing here. The only thing is one extra element to that is that, okay, if you are using parse, okay, so basically what I'm doing, I'm actually taking the input, I'm reading a line and I'm storing it in the input, and then input I'm trimming so that all the spaces are removed, and then I do a parse. So if this is I32, it will automatically parse that string into I32. But this parsing can fail, right? So for that we use the dot expect. So this is the extra thing that you're doing. This is similar to writing, you know, try catch blocks in Java. Here it completely avoids that by putting up, hey, if this parse works, whatever is the value, you assign it to n. If the parse fails, then produce this error message. That's all. Because parsing, you cannot, say for sure that the parsing will always work, isn't it? That's the difference. Okay, Puneet? Okay, guys. So I think maybe we can take a 10 minutes break, 5 7 minutes break, something like that. Deepak.
Yeah, okay, so
So what
Yash
time?
will keep the meeting live for so it's
The
8
timer to
6.
10 minutes. Yeah, 8 6.
Yeah, it's 8 6. Let's reconvene at 8:15. Everyone,
Yeah,
make sure you're on time. We will begin
yeah.
immediately at 8:15.
Okay. So yes, you can just pause the recording and we can restart it.
Yeah, it's okay. I think we can continue.
So I'll go on mute and I'll come back at 8.
Yeah, yeah.
Hey guys, are you able to see my screen?
Yes, sir. It's on.
Okay, right. Okay. I'll just comment this out and create a new main function and start up. Okay. So this time around, what I'm doing is I have got a variable n. So let's say let n is assigned 55. Okay. And I call a display function with n, or maybe client is so there's this value of n is 55. So this is just fine. So I'm going to define a very function. Okay. Let's define this function as a one or odd. Okay. If and it takes in x to the right 32, it's parameter. So if x modulo 2 equals 0, okay, and then yeah, else and odd. Okay. So this. Now I just call even or odd and pass in the value of n in there, and we run this. So 55 is odd. Now see what happens. Okay. And it's line. After calling the function, value of n is n. Let's say this. Okay. Value of n is 55. So this is working this way. Okay. However, if you have a complex type, then things are quite different. Okay. So something pretty strange actually starts happening in there. So as far as primitive data types are concerned, they are just fine. Okay. Now let's say I create a tuple. So let's assign say 10, 10 like this. let's access the tuple and client. Okay. Did I forget something? I32 and the reference. Okay. I32 and then F32. And here I'll just change it to 5.6. Okay, right. So let's run this code and see. So I'm getting tuple as 10 and 5.6. And now I add another function. Okay. Let's say let's make it I32 board ticket. So then I create a function called sum, okay, and it takes a tuple T with I32, I32, and it returns the sum of the values. So that's again an I32, and I'll just give that T dot 0 plus T dot 1. And I'll just call the function. So let's say let total is assigned sum and passing the tuple, and the front line sum of elements is called the total. And we're getting it as 15. Okay. Let's see the tuple after calling this. Okay, so incline after calling the function tuple is okay. Okay. So now if I run this, so my tuple is clear. Okay, that's fine. Now, as far as these tuples are concerned, okay, so these are handled in a very different way, right? So these sizes are all known by the compiler at compile time. But if I were to use a string, then things become very different. Okay, like for instance, I create a string. So let's say let username is assigned okay, um, string from string as let's say A, B, C, D. Okay. So let's print it out. Username is username. So username is ABCD. That's it. Now what happens is that suppose I want okay another function. Let's say, let's call this out capitalize. It takes in say user, or let's just say name, and it's of type string, and it returns a string. Okay, and it's a name dot to uppercase. And implicitly returns so what does this return? To uppercase returns. Okay, that's the fine. So fine. Name, capital, and I call the function capitalize and I pass in this. Okay, so let's run this and see. Oh, okay. Expected touch string found this. Oh, I'm sorry. Wait, even I made that mistake. Okay, right. So instead of the tail expression, it actually became a statement. Okay. So ABCD is in capital. Okay. Now let's see what happens if I print. Okay, function username is okay. Now you see, you start seeing this QB line. Hey, borrow of moved value username. Okay. Value borrowed here after move. So error originated from macro call in here, blah blah blah, whatever. That's just fine. Okay. So move occurs because username is type string, which does not implement the copy trait. Oh, we will understand about this. So basically, what is happening here is that a string, okay, is a very different data type. Okay, so you have to understand some fundamentals. So let me just show you. Okay, so okay, I'll just show you what is actually going on. Okay. So essentially what happens is, this is, now you have to look at it very carefully because this is extremely important for you to understand. Okay. If you look at the memory layout, okay, and okay. So in Rust, what happens is the memory layout consists of two parts. Okay. One is you have, this is your stack, and this is the heap. Okay. So as far as stacks are concerned, okay, inside the stack you will have all the scalar types and statically allocated types such as tuples and array. These are all stored in here. Okay. So the scalar types and the statically allocated types such as tuple and array. So what does this mean? It means that the size of entities is known at compile time. The compiler knows what is the size I need. So accordingly, so if it knows that, it is going to put all this into the stack. Okay. Now heap is used for dynamically allocated types. Okay. Is not known as compile time. Okay. The memory allocation is dynamic. That is during runtime. So therefore, the compiler has no way of knowing beforehand what is going to be the size of these. Okay. So what are the types? Primary types are string, vector, okay, map. So whatever is allocated on heap, okay, it uses a different mechanism altogether. So a string is actually a heap allocated type. That is, it's a dynamic data type. Okay. So with the types which are actually statically allocated and the types which are actually allocated on the heap, the internal working is completely different. Okay, internal working is completely different. how this thing actually works is like this. So we can actually see it. So let me just put up a line to segregate this. Okay. So essentially, if I take, suppose for instance, I have, let's say, a variable, and it has got the value 55. So let's say this variable name is n. How is this created? When I use the, let's say, let n is assigned a 55. So what happens is some memory is allocated and is stored over there. Okay. And at some point in time, okay, I say let x is assigned n. Okay, something like this. What will happen is a new variable x will be created and the value basically gets copied in here. Okay. Right. So the value is getting copied in here. So when you do a assignment like this, what happens is that the data is copied into. Now, if it is on the heap, then things work very differently. So suppose if I create string variables, okay, then things are very different. So let's say I create a string variable, okay, let's say let say s, which is of type string, is assigned string from, let's say, A, B, C, D. If I do it like this, you know what will happen? What will happen is like this. So this variable s is going to get created and it will get this value A, B, C, D. Okay. This is what is going to happen. Now later on, okay, if I create another variable, say even if I do something like, you know, let s2 is assigned s1. If I do it like this, okay. So something different will happen. Actually, this whole thing is actually very different. So this ABCD is created somewhere in memory, and let's say this has got address, say 1, 2, 3, 4. This is the address, okay. So this S will actually contain 1, 2, 3, 4, basically indicating that this S, okay, is pointing to this, okay. This is what is happening. And this is our S2. So now when you do S2 is assigned S1, okay, you know what will happen? So basically your S2 is assigned not S1 but actually S, or let's do it as S. Okay. So in this scenario, what will happen is what you are copying is the address 123. So after this, what happens is this pointer moves from this to this, and therefore S no longer holds this value anymore. So we say that the ownership has changed the hands. So basically, the ownership of the string ABCD, which was initially with S, once you do assignment, what happens that ownership actually is changed over to S2. So S is no longer pointing to anything. Okay. So in Rust, there is one fundamental rule, and that is you can have only one owner at a time. Of course, you can have multiple readers though. Okay. You can have multiple readers. So this is exactly what happens. So what we are getting delving into is essentially ownership. So when I called this capitalize and passed in the username, because username is a string, okay, so the ownership of that string goes to this value name, to this particular string. Okay. So after calling this function, username is no longer holding that. Okay. So what has happened is this is called as move semantics. We call this movement as called as the move semantics. So when you take a reference, okay, basically it's a reference type. Reference type means internally it is represented as a pointer. Okay. So if you take that and use it, then what happens is basically assigning two references would mean you are changing the ownership of the source reference to the destination reference. And now the source reference will no longer point to anything. Okay. This is called as move semantics. This actually avoids a lot of runtime memory related issues. That's the reason they are using it like this. Okay. So what you're seeing here is kind of the ownership itself. It's the ownership problem. It's not a problem. It's actually a feature. We see it as a problem because this is not what we expect if we are coming from a regular programming language. Okay. Any questions here, please? Can you please show the old diagram? I have to take a screenshot. Okay.
Selva sir, just a reminder about
Okay.
15 minutes.
Mm-hmm.
Have time?
So I think, yeah. So I think I can close it here. Now I've just finished. So those of you who want to take the screenshot, you can do so. This is called as move semantics. So essentially, we have already gone into the ownership, property of Rust. Okay, and we will see, more of this in the upcoming session, where you will get a much better understanding of how to use this. It's actually very useful. No, it's not like something that you have to worry about. Okay. Let's see if we can export this as a PNG. Let's check. So let me see if we can put that up in the chat. Oh, we do have web select and web capture. Okay. Click and drag to start selecting. Okay. Oh, it is actually doing it in the same screen. Share the main RS and Discord will practice the code. Oh, practice doesn't work. Okay, let me see if we can. Okay, can we do? Okay, I'll put that up in Discord. Okay, this whole code. So let me just do it right away. Okay. Anyway, so Deepak, are you ready with the quiz?
Yeah. So, Sarva, sir, you want to introduce that?
So, guys, so as we mentioned at the outset, okay, you will have quizzes coming up in between. So today is the first quiz, and so you have to have some basic, score that you have to obtain in order to be able to get the completion certificate. Okay, so it's very important that you do the homework and read the material and stuff like that. Without reading material, believe me, guys, no matter how many number of sessions you attend, it will still not be complete enough. Okay, so you have to do the homework on your part as well. Okay, so I think Deepak, you can start. So meanwhile, I'll
Yeah,
just take that code and put it in the code.
sure. So, guys, I have just put a link in the chat here in the Q&A chat, right? Link for today's quiz. So what we'll do is you have 15 minutes to complete it, and which technically is around 9:05 p.m., right? So after that, we will stop accepting responses. So we will be taking this into consideration for evaluating your progress, and obviously the next steps that I mean to move you towards the next module and other completion certification and other things, criterias that are required to evaluate your progress. So make sure you start working on it. Please fill the questions in the next 15 minutes. Your time is already started, so the end time is 9:05. So make sure you do it by then. We'll stop accepting responses post that, and the call will be on over here. If there is any specific doubt with respect to the quiz, just put it in the Q&A section, and don't put the questions over here. We are not going to answer it for you. guys, 3 more minutes, I guess. And do we need extra time? If you think so, then you can just drop in the chat, and depending on how many responses we get regarding extra time, we'll decide. We've got a few responses by now already, so I think people are able to go through it. Okay, so 1 more minute. What I'll do is I'll give you guys 3 more minutes, so we'll end it at around 9:07 in case anybody needs it. an amazing anomaly. All the responses that we have received until now is all by women, by girl students. So kudos to you guys. I mean, the guys are falling behind, I suppose. Anyway, just in case if somebody is missing out, I'll just give 2 more minutes to complete. Okay. Now starting to see some guys. Yeah, you guys are falling behind. All right, guys, time's up. I don't think anybody's. I mean, the amount of time that we have given is enough for. I think there are 15 or 20 questions. Okay, we'll stop accepting responses now, and I want to thank you all once again for joining in. Salwa sir, any concluding remarks you want to share with us?
Thank you guys for your patience, and I wish to give you a small assignment. Okay, and that assignment goes like this. Number n, say 5. Okay, and display 5 Fibonacci numbers. That means it should be like say 1, 1, 1, 2, 3, 5. Okay. Now, also one more thing that you have to do is, so the next part is um, add an even odd function, and the output should be like this. Okay, so 1 is a odd, 1 say odd, odd, 2, even, and 3, odd, 5, odd. The output should now become like this. So you use the same 5 Fibonacci numbers, 1, 1, 2, 3, 5, and you get 1 and then odd. So first output is I want 1, 1, 2, 3, 5, then 1 odd, 2 even. Okay. Now suppose then another third part. Okay. Now write a function to test if a number is prime or not, and then use it for Fibonacci numbers. Okay, and it should be like this. Now the output should be should look something like so. Basically, it should be 1 odd. Okay, and for 1 and 1 you can actually leave it because
Hello.
1 is neither a prime. Hello. Okay, so for 1 and 1 you just put unique. For 1 and 1 odd, unique. Now from 2 onwards, 2 even and it's prime. Then the next number is 3, which is odd and it is prime. Then you have 5, which is odd and also prime. The next number would be 8, is even, not prime. The next one would be 13, is odd and also prime, like this. Then you have 21, odd, not prime, like this. So I hope you got the idea, right? This is going to be hard. Hey, come on, Puneet. It's not that hard. Sir, you haven't shared your screen. Oh, I'm sorry. Okay, so let me show you. So first, let's say you input a number, let's say 5, then you display this Fibonacci numbers. Again, write a function to generate these numbers. So 1, 1, 2, 3, 5. The next part is add even odd testing function, and then when you do this output, now the output should become 1 odd, 2 even, 3 odd, 5 odd, and so on. Then the third part is now you add a prime testing function. So whether a number is prime or not. Now you should see the output like this: 1 odd unique, 1 odd unique. You can leave this because 1 is neither prime nor not prime. Okay. So in that sense. So for 1 and 1 you can leave it. From 2 onwards. So 2 is even and it is prime. 3 is odd and prime. 5 is odd and prime. 8 is even and not prime. 13 is odd and prime. And 21 is odd, but it is not prime. So like this, the output should like look like this. So ultimately, this is what I wanted to do. I hope this is clear to you. Okay. Right. Okay, guys. So during the weekend, you can practice this. Okay. And try to do it all by yourself. If you are having any difficulty, we can discuss it. I'm sorry, I'm not able to put the source code in the Discord. It is actually, it's not accepting it. So what we will do is we'll put it in Google Drive and share a link to you. Okay. Okay. So thanks for your patience. So I'll see you in the next session. Okay. And yes, please keep reading that Rust book. Right. Because once the rest sessions are over, you will have to have all that background knowledge to understand substrate and make use of it. Okay. So thank you all of you. I'll see you in the next session. Bye bye. Thank you, Deepak.
Thank you, sir. Thank you, dear students. We'll catch up soon. Wait for our. You might already have the calendar.
just make sure you check it for the next session, and obviously we'll be keeping you informed on Discord as well. Okay, thank you, sir. Bye.
Okay, bye bye.